So this is a series of videos that we're going to find the aesthetic side of mathematics. So what we try to do, we try to find problems that have either the problem is like have like a nice format, or the answer has a kind of beautiful format. So as the next problem, as a fourth problem, we try to find a particular integral. So the problem number 4. So what we're going to do is we can evaluate this integral. So what's the integral? Sine inverse x dx. So normally if you get a problem like that, we are directly going to use the integration by parts technique. So that's one of the way to do this problem. But rather than that approach, what we're trying to do in this video, we're going to transform the problem using a like a non-traditional approach. So what we're going to do, we're going to take this part as theta. So we're going to say theta equal sine inverse. So this is not how we normally do this problem. We use integration by parts directly, but we do that. So if this is the case, then we know that this sine theta equal x. Now what we can do is we can take the derivative of both sides. So if you take the derivative, dx equal cosine theta d theta. So that means now you can transform your problem into different types. So what's going to happen, this problem now becomes so sine theta is theta, so this is theta, and then dx is cosine theta d theta. So you can see that this problem is much easier because this is like in a common problem in integration by parts that we normally do as the first or second example. So let's use the integration by parts approach to finish the problem now. So what we can do, u equal theta, and then dv equal cosine theta d theta. So and then du equal d theta, v equal sine theta. So that means if you're gonna get that, that means your answer gonna be theta sine theta minus we're gonna get sine theta d theta. And then also this is very easy to integrate. So theta sine theta minus this is sine, so it's become a negative cosine. So that means plus cosine theta plus c. Now what we're gonna do, we're gonna substitute for this using sine theta, but we can do that. This is theta sine theta. Cosine theta is 1 minus sine square theta square root plus c. So if you plug into theta, so the sine inverse sine theta is, so we're gonna get x sine inverse x plus 1 minus x squared square root plus c. So this is a different approach rather than the traditional way to do the problem.